we want to bring to that construction project. This is a recent project in Cable Beach. That was some of the team that was there for helping with the kickoff and startup. One of the things we incorporated from day one was a good catch scenario where we go out and people have on their phones the ability to click on this application. This is clicking on make a report. That's what you see over here. And if you see a good catch or near miss, that's where you see something that could be an unsafe condition or hazard at the site. You just click on that, you take a photo, you type in a few lines, and boom, we have a good catch. And the same day, we'd have a discussion about what we need to do to fix it. And that was getting fixed the same day. So this is a key aspect, a real simple solution of something that could be on the phone that I just saw locally. By having this, everybody who worked on the site, every contractor bought into this, and it was a good way to get the safety culture really up for everybody who was there. And these are some of the things that we saw. Like right here, this was a new concrete berm that was put in. This is the ground level next to it, and this was soft material right here. So anybody, if they tried to walk along here, they might have twisted an ankle. So we caught it pretty quickly. We started to backfill it, and then we leveled it out, and then it was no longer a slip, trip, and fall hazard. Over here, we had open trenches where we were recovering oil, and based on some massive storms and drainage that we saw, we had a couple caverns that opened up, shallow just pits that opened up, where stormwater came in and eroded in. So we went in, we put sandbags, concrete, and we also diverted that storm water so it didn't come here anymore. And this was a new platform that was built with this step. There was a piece of rebar that was left, so we needed to remove that. We needed to bring the soil up to this level, and we needed to anchor these platforms into the concrete. So pretty simple. Each of these just took about 2 minutes to do these. And then the same day, usually within an hour, the fix and repair was made. And having that application and doing that not only made it easy to capture it, it just brought everybody's behaviors into the mix, that it's a routine thing to look for those aspects. This was a situation where the client had over 20,000 water samples being collected in a short period of time, 12 months. So, this could be many different things. This could be geotechnical samples. It could be inspections or audits of roads. That you have a ton of work to do in a short amount of time. All the old data was migrated in. Some of that was collected before we had a data management system. Forms were developed for everybody, and pretty quickly, this tool was put together so that you could visualize. You go into the website, you click on the different boxes, what you want to see, and you see the data being reported on top of the aerial map. If you want to chart it, you click on a button and you chart that. You can zoom in and see those locations, who were the residents that samples were collected from, and so forth. So just one example there. This was an erosion and sediment control issue, and on this one, I remember the client saying, we keep getting compliance issues from the regulator because we keep having erosion issues. We're doing inspections, but by the time the inspection report gets to the right person, it's taking a while. And then the regulator goes out, and the regulator issues a violation. And we looked at it, and it was taking, I think, around 30 to 40 days for that piece of paper to get to the right person. So we put a real quick solution together with a field form, and that data went to the right person instantaneously, not 30 days. And also, if it wasn't followed up on, there were additional emails that were elevated to different people. Until it was checked that it was fixed, it would still send an email daily to people to remind them. So where it might have been taken care of in 40 days, things were being taken care of within 2 days typically. And then they no longer had any erosion sediment control issues. And some of the issues might have been that they were required to have these sediment traps in, and maybe some of that had fallen in and wasn't there. If a regulator went out, they would have seen that and issued a violation. Waste management, here's another example. The client didn't really know where their waste would go, and they had no way of tracking, understanding those liabilities, those risks. When you're getting rid of waste that could even be hazardous waste, and you don't know exactly, you're not 100% sure where it's going, that could be a major risk down the road and problems and liability for you. So here we put a form together that really followed the truck when it came to pick up the waste and where it disposed of it, that it went to where it was supposed to go to, and it was verified, and it was really kind of an automated manifest. And in this case, waste was going places that the client didn't know it was going, and that's some scary liability. So, from a Ministry of Public Works standpoint, you could have a tool for your workers, or if you wanted to, for the public, that you just click on to report potholes and or other road hazards. These areas where you have some subsidence, or people can report. This is a bridge that has a significant crack. Pretty important to know about, right? So whether this is your own inspectors and staff have a button that they can click on their phone and report something like this, or in some cases we have clients that want the public to do it. A lot of government agencies create a website that the public can as well. So it can be pretty simple, and you can know about these things immediately, and you can also see the photograph and the GIS reference on a map of where it is. And then this is another thing you can do is track construction project. So this is the project I was referring to in Cable Beach. So we used a drone to get aerial photos. We show all of our wells and data points that we were collecting here from this aerial photo. We would collect a new aerial photo, at least once a week during construction, so that we can see what progress we were having in constructing these waterways here. And these were waterways to get oil out of the ground. Here's another view from the drone looking at the equipment. But think about it, if a major activity is happening at your job site, maybe a piece of equipment is being delivered, and you can either have video or photographs that show real time that same day the progress that's being made. It makes you feel like you're at the site without being at the site. And this is from yesterday. These are the still shots of the cameras that we have, 4 of the cameras that we have at the site. So we had 2 trucks coming to pick up the oil. Let's say there would be an oil spill or some kind of incident would happen. We could go back in the log and see if the contractor made a mistake and what that mistake was. So it's a way to also protect the assets and make sure that the equipment's being maintained and even nothing's being stolen out of the equipment compound as well. So real-time cameras, think of all the new infrastructure projects you had. Imagine if you had real-time cameras at every job site as it's in construction, especially some of these ones at other islands. That could be a good thing for you. Construction project, this is the Ministry of Public Works project at Clifton Pier. This one photograph, I know I probably used it during the coastal resiliency talk last year too, but it shows the progress of this barrier wall, and then what was remaining in the wall was down to here, and you can see the oil still coming out of the rock there. That is no longer coming out because you extended this wall that now comes into here, and this whole area that oil was seeping out is now taken care of. So those of you that are managing a project like this, imagine if every day you got a photograph like this, and you can see the day in by day out project or progress. It's a way for you to manage your project without being there. And these are some of the daily construction reports from that project. Now these were done on paper, but easily could have been done if you had a data management system. If any of you wanted to know what was going on that day, what happened today, how much progress was made, you could visually see it. You could also see, how the workers were doing work. If there's a problem in the future, you can see every segment of the construction and go back to that information and see if there's any problems. It looks like in this photograph that somebody might have had a hole in the liner and they're doing a manual fix of that liner. So that could be a major problem down the road. So to visualize that and identify where that where that is pretty important. And then cut off at the top, but similar on geotechnical work. This was a geotechnical project that a barrier wall was being installed and geotechnical data was being collected in real time. And it was through a website that people could click it on the barrier wall information. As each point was coming in, the data set was coming into the table. And you can do a cross-section. Somebody clicked on the box to see a cross-section of the subsurface from every point that was being installed. Now, an example here is, let's say you're looking at a site and you find a major void where you're going to build a new school on top of. And while they're in the field, you can now tell them, hey, we can't move on. We need to go in every direction from this void to see how big it is, because this could be a major structural issue for this new school that's being built. And by doing that in real time, you can tell the contractor and get them to not leave the site without collecting that key data. And one of the simple things from this was on a phone, sample location. It just caught your reference where you were standing. You gave it an ID, and then you also put the data point and the result that you were getting from your meters in that, if that was a handheld meter. Other things, like there was data sets that were being, geotechnical samples were being pushed down into the hole. The drilling was downhole, the meter was downhole, and that was real time. That data was going from that meter into the database. Visualizing things too, so now you can take that data and you can automatically visualize it. So maybe that same geotechnical contractor is in the field and we have the data set being modeled automatically. Rob, maybe you're in your office and this project is on another island, and as the data is being collected, the visual is expanding. And you say, hey guys, we need to do something about this data that we're seeing here. Instead of wasting the rest of your day over here, let's extend the rest of our time here to this area and really understand what could be a major risk and hazard for the structure you're building. And this is showing the surface. This is showing a 3D model of different sampling points and data sets. For you, those of you that some of you manage environmental projects, and that could be environmental data, that could be geotechnical data, but you get a 3D understanding of what that is. And then you can take the model to run the history of your data set. So let's see if this runs okay. So this is showing water level changing in the subsurface, and this is showing the thickness of oil on the water table as it fluctuates up and down. So this was an environmental project. Pretty interesting to see. At one point you're going to see a major change in this moving over here, and that's when the recovery system was started. So you can see things fluctuating over time, getting larger and larger. Then this recovery system starts, and boom, that oil is pulled over and recovered. And then the rest of this is where the treatment was and the subsurface recovery was. Pretty cool to see this data, right? So by looking at a table on paper, I could have never understood what was happening. By putting it in a visual like this, I understood what was happening. We also identified a new spill that occurred here because we saw increases after this was remediated. And after about a year, we got to where we needed to get to with cleaning that up. But again, if I'm just looking at tables and pieces of paper with that data set one after another, I'll never understand it like I did by having a quick visual. So this is where we helped, again, client with geotechnical data for a major dam project. And the data was coming in as it was being collected, and the model was being built as it was happening. So allow the large stakeholder group to be communicating as data was coming in on a pretty massive infrastructure project, pretty high risk and important infrastructure project, because that's a pretty massive dam and levee system. Other things I want to show some examples, some other sensors. And there's sometimes you get involved in some culvert projects and so forth. So this is showing a culvert where you can have a device that looks at It's a sensor that does two things. It measures how much level of water is in here, and then what the flow and the velocity is. You can get that level and that velocity to get your flow rate out as well. You can also use that data and other data to model your scour of how much, what area might you have an issue with after that drains out of it, and how can I put riprap or some other geotechnical or engineering structural item here to not have a problem because I just installed this culvert. The other aspect is there's a lot of fiber optic strain monitoring that can be done. We do this on everything from roads and bridges to even large pipeline projects. You can see the fiber optic lines.